students, let us now start with Fresnel's biprism experiment. Students, in order to study steady state interference pattern, we have already done one experiment, and that was nothing but known as Young's double slit experiment. Now this was the very first experiment to determine wavelength of light. Now we would be moving to Fresnel's biprism experiment, which is another experiment where we determine wavelength of light. And you might be just knowing that this new word biprism is having very great significance in this particular experiment. So let us start with Fresnel's biprism experiment. Students, what is biprism? What does this consist of is the main question at the brain now. So we would be saying like biprism is nothing but it is made up of two different prisms, and that too two different right angle prisms. Now when these two right angle triangle would be meeting together and they would be forming nothing but a prism, so this angle, that is resultant angle formed right now, is looking somewhat close to supplementary angle. And if this is somewhat looking close to supplementary angle, then this angle would be nothing but 178 degree to 179 degree, students. Now this angle is responsible for creating two virtual sources. That is, the main ambition behind using biprism is nothing but we wanted two coherent sources, because you know this is a condition that whenever you want to obtain a steady and clear interference pattern, one of your conditions is the two sources should be coherent. What does coherent mean? That they should be having all those properties like amplitude, intensity in same format. And coherent sources are something which are obtained from one single source. So in order to obtain coherent sources, we would be using biprism in this bit. We would be using biprism in this particular experiment. So students, 178 degree to 179 degree, this is nothing but the resultant angle of the prism, which is nothing but very large. And you should also keep in mind that this biprism is going to create two virtual sources. Now let us try to understand that how does this going to be performing, means how it is going to perform and make two different virtual sources. Let's have a look at that. But before that, let me explain you what are going to be the important components of this experiment. We would be having a source first of all. That source would be emitting light, and we would be keeping a convex lens in front of that source. And in front of convex lens, I would be keeping this biprism. Now why convex lens is used between biprism and source? Convex lens would convert that source into one single source, and that one single source would be converted to two virtual sources by biprism. And in order to see that interference pattern obtained by two virtual sources, I would be considering a screen which is kept at a distance from biprism. So now students, light would be coming out of the source, it would be converging and it would be moving towards biprism, and biprism would in turn produce an interference pattern on the screen. Now when this interference pattern is observed, what we see is nothing but it is looking like it is obtained from two virtual sources. Now these two virtual sources are nothing but obtained by this biprism, and these two virtual sources help us in interference and making the patterns very clear. So students, this is how the biprism experiment is going to be performed. That's it from this particular module, students. Let's see how the ray diagram works in the next module. Thank you.